Okay, so in this quick video, I'm just going to give you a rundown of recurrence relations. So this is what a recurrence relation looks like. You generally get a V0 term, which gives you some number, and then you have a Vn plus 1 equals, and it could be any number of things, but some of the typical ones look like R times Vn, or you might have a different one. V0 equals B, and Vn plus 1 is Vn plus D. Or sometimes they do a bit of both. So V0 is equal to C, Vn plus 1 might be equal to R times Vn plus D. So basically what they mean is to find this term, so say term number 5, you need to know the term that came before it, term number 4. So n plus 1 and n just mean the term and the term that comes after it. Generally speaking, the sort of way that we look at it is Vn comes before Vn plus 1, which comes before Vn plus 2. So they go in that direction. But another way to look at it is Vn comes after Vn minus 1. And that comes after Vn minus 2. So they're all relational, basically. They're just talking about terms in a sequence. And so let's have a look at how they work. So here's a recursion relationship. So here's V0, so term 0. We're going to make that 10. And Vn plus 1 is equal to Vn plus 7. That means that the next term in the sequence is equal to the last term you had plus another 7. So V0 is 10, V1 has to be V0 plus 7, which is 10 plus 7, 17. So V2 has to be V1 plus 7, which is this 17 plus another 7 is 24. And if I want to go in, V3 would be that 24, V2, plus another 7, which is 31. Similar things, if we were to do multiplying instead of adding, so if I change this to be V0 is equal to 6 and Vn plus 1 equals 2 times Vn, basically all I'm going to be doing is multiplying. So V1 is equal to 2 times V0, which is 2 times 6 is 12. V2 is equal to 2 times V1, which is 2 times 12, which is 24. Sometimes you might be given a term in the middle of a sequence and be asked to go backwards. It's not all that common, but sometimes it happens. You might be told that Vn plus 1 is equal to Vn minus 10. And then you get told that V4 is equal to 53, and they want you to find V2. So what we can do with this expression here, if this helps us to go forwards, but if we want to go backwards, we're going to reorder it. So we're going to go Vn plus 1 is equal to Vn minus 10. I'm going to add 10 to both sides using classic algebra. So we've got Vn plus 1 plus 10 is equal to Vn. And this will actually help us to go backwards. If I rewrite this, Vn equals Vn plus 1 plus 10. Let's have a look at how that's going to work. We've got V4, so we've got V4, and we want to go backwards to V2, so V3 is equal to V4 plus 10. 53 plus 10 is 63. And I go back another step. V2 is equal to V3 plus 10, which is equal to 63 plus 10, which is equal to 73.